Welcome back, Bafundi. Now you may have noticed that the leaves of a potted plant next to a window will always bend towards the light. If you expose a shoot to light from one side only, the shoot will bend towards the light, as in Darwin's experiments. The shoot is therefore positively phototropic. In a shoot that is receiving light from above, as plants would when growing outside, the auxin is made in the tip of the shoot and moves down the stem, promoting growth. Sunlight reaches the plant from all sides equally. Therefore, there is an equal distribution of auxin. Therefore, the plant grows straight up. However, if the light stimulus is unidirectional and only one side of the shoot receives light, then the auxin will move away from the light to the dark side of the shoot, where the greater concentration of auxin will stimulate growth. The greater number of cells on the dark side will cause the shoot to bend towards the light. The stem is considered to be positively phototropic. The phototropic response of shoots can also be explained by the uneven elongation of the cells due to an uneven distribution of auxin. In bright light, auxin is made inactive, so the auxin on the lit side of the plant has less effect than the auxin on the shaded side of the plant. This causes less elongation of the cells on the lit side of the shoot, which causes the shoot to bend towards the light. Now, some learners conducted the following experiment. Firstly, they chose two potted geranium plants that were about 15 centimeters tall. They labeled the plants A and B. Second part, they used a sharp knife to cut off any lateral branches of both plotted plants. This ensures better growth of the tip of the main stem. Third part, they put the plants in a place where they will get sunlight from all directions during the day. The fourth part, they left the plant A uncovered. The fifth part, they put a cardboard box over plant B by cutting a hole in one side of the upper part of the box. The hole was in line with the upper parts of the plant stem. The sixth part, they left the plant for 2 days. Seventh, they removed the box from the plant and compared the plants. The learners made a hypothesis that was ultimately upheld by the investigation. What do you think their hypothesis was for this investigation? Well, was it A, plant shoots are negatively phototropic? Or B, plant shoots are positively phototropic? Their hypothesis was that plant shoots are positively phototropic. Now, in this experimental setup, which plant is the control? Now, I hope you can see that A is the control. It is not subjected to a one-sided light source. What is the independent variable? Would it have been A, the direction of the sunlight reaching the plant, B, the growth movement of the plant, C, the size and type of plant? The plants are placed in the same place. Can you figure out which one it is? The independent variable is the direction of the sunlight reaching the plant. So what was the dependent variable? Was it A, the direction of the sunlight reaching the plant, B, the growth movement of the plant, or C, the size and type of plant? The plants were placed in the same place. The dependent variable is the growth movement of the plant. Now, what are the fixed variables in this investigation? Is it A, the direction of the sunlight reaching the plant, B, the growth movement of the plant, or C, the size and type of plant? Now, the plants again were placed in the same place. The size and the type of plant, and that the plants were placed in the same place, are the fixed variables. Now, what would the learners have observed about the plants? Well, they would have observed that the shoot in A continued to grow upwards. The shoot in B bent towards the light. From their observations, what conclusion do you think you could reach? Well, they should have been able to conclude that the plants are both positively phototropic. You can do similar experiments of your own in your classroom. Modern techniques have shown that the action of auxin is very complicated, and scientists are still working to find out exactly how auxins work. I'll see you right after for our final segment.